How many of these molecules are polar? An overview of what I'm going to be doing is drawing a Lewis structure, identifying partial charges, identifying the net bond dipole, and the result. So I'm going to draw a Lewis structure of BeCl2. It has 16 valence electrons, 7 of which are from the chlorines, which there are 2 of, and 2 from the beryllium. So that gives us 16 electrons. The first thing we do is draw a bond between each of the atoms, and then we fill the outer atoms with electrons until it has an octet. So now that it has an octet, we can add up how many electrons were used. 1, 2, 3, 4, 5, 6, 7, 8 pairs. And that's 16 valence electrons in total. And now we see that the beryllium doesn't have an octet, so we take away a pair from each of the chlorines and add another bond between each one, and that gives us an octet between each of the atoms. So now we identify the partial charges. The partial charges are based on the electronegativity of each of the atoms. Chlorine has a higher electronegativity than beryllium, so we say that it is delta negative, and that beryllium is delta positive. Now number 3, we identify the net bond dipole, and the net bond dipole is going to be facing towards the chlorine because it is electronegative, and the other chlorine. So in this case, the bond dipoles both cancel because they're facing opposite directions, and that gives us a non-polar bond. The next example is SO3. It has 24 valence electrons. I've already drawn the Lewis structure of it, and so we're going to identify the partial charges. O is more electronegative than S, so it is delta negative, delta negative, and delta negative. The S is delta positive, and the bond dipoles are going to be facing the oxygen because it is more electronegative. So each of the arrows are going to be facing the oxygen. And in this case, again, there is no net dipole because each of these cancel, and that gives us, again, a non-polar bond. The next example is OF2. It has 20 valence electrons. I've already drawn the Lewis structure again. So the partial charges of this one are going to be towards the F because fluorine is the most electronegative atom. So it's notified as S negative or delta negative, and the two lone pairs are going to be delta positive. So the bond dipoles are going to be once again facing the electronegative atom, which is fluorine. So they're going to be like that. And because of the lone pairs being there, it changes the molecular formula of the molecule, and it makes it bent. And as a result, since it's bent, it makes the net dipole going downwards. These dipoles don't cancel, and as a result, the bond is polar. The next molecule is CCl4. It has 32 valence electrons, 8 around each chlorine, and 8 shared with the carbon. Once again, chlorine is the more electronegative atom, so it's notified as delta negative, 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 and the carbon is delta positive. The net dipoles are going to be facing towards the chlorine because it's electronegative, and in this case all of the bond dipoles cancel, and there is no net dipole, and so it's nonpolar. The last example is O3. has 18 valence electrons. I've drawn the valence, or the Lewis structure here. However, all of these are oxygens. So how can one be more electronegative than the other? Well, the lone pair on the oxygen in the middle creates a slightly positive electronegativity, and as a result, these oxygens down here are more electronegative than this one, and so it's delta negative, and delta positive, and the lone pair again changes the shape of the molecule and makes it bent, and so the net dipoles are facing away from each other and not opposite, so it makes a net dipole of down, meaning that the bond is polar. So for our result, how many of these molecules are polar? OF2 was polar and O3 was polar.